Over the weekend, I wanted to experiment more with Deepseek-r1, so I just came up with these 5 different experiments I wanted to try to figure out. So the first one is we're gonna do some coding. We're gonna challenge both O1 and Claude 3.5 to create a 3D browser simulation that kind of tries to take this wind tunnel and particles, so we can see what model can create this using, just HTML coding. AI agent tool with tool use, that's going to be our second challenge. So I wanted to kind of combine 2 models so we can use Claude with their tool use and function calling and try to get DeepSeek into the mix, so we can also use the reasoning tokens we can extract from the models. That was pretty cool. And just a fun thing, analyzing the reasoning tokens from this fun prompt I think I saw on, was it Reddit maybe or somewhere? It was pretty cool, so you're gonna love this one. Number 4, we're gonna try to break free from the training data by using an alternative of the river crossing puzzle. So this is a puzzle often used. There's the man, there's the wolf, there's a cabbage and the goat. We're gonna do a variant of this and see if the models can actually separate from the training data and come up with their own conclusion based on the user's request. And finally, I just have my own reasoning test I've been playing around with this weekend. We're gonna run this to DeepSeek and O1 and compare the results and extract some knowledge from that. So yeah, we're just gonna get into it. Start with the first challenge. That's gonna be some coding and move on through these 5. I think you're gonna enjoy it. So yeah, let's have a look. The first test I wanted to do today was actually a coding test. So basically, we're gonna run to Deepseek-r1. You can see I've selected the reasoner model. This is the full model. We're gonna pick Claude 3.5 Sonnet, and we're gonna pick O1. So that is gonna be our competition. So the prompt is just gonna be, we're gonna do an assignment and write code to solve the problem. And you can see we're just gonna read the assignment from the story.txt. And here is our assignment. Create a 3D animated browser wind tunnel simulation with wind speed and direction adjustments and transparency settings for the particles. In the middle, there's an adjustable wing that can be rotated and tilted. The particles should be visible and the wind should be visible to show how it affects the wind, or how the wing affects the wind. Also include controls so we can look from all angles. So my plan is to run through Claude, O1 and Deepseek-r1, and we're gonna compare the results. So let's start off with Claude here, I think. So you can see now I just selected Claude the prompt, and we're gonna print that. So let's do python main.py. Yeah, you don't have to watch this. So I'm just gonna wait for this. We copy the code and we see how the animation looks. Okay, so that was Claude finished. So let me grab the code. We're only gonna do like a one shot here. We're not gonna iterate. So just copy the code. So we have a Claude sim.html here. Let me save that. Let's open it and see how this looks. So, okay. Yeah, that didn't seem to work. Okay, so that was Claude 3.5 Sonnet. Not too good, not too good. Okay, that's fine. Let's move on and select, yeah, we can just do O1 first. So here you can see we have selected our OpenAI model. So let's just run it again and see what we can get from O1. So I'll take you back when the code is here. Okay, so we have the code back here. Of course, it's a shame we can't see the reasoning tokens. But you can see we have the explanations of the major parts here. Transparency, animation, rotation. So it looks pretty good here. So let's grab the HTML. So I think every single HTML here is using 3.js. Okay, so let's copy that. Let's go here. Let's do OpenAI sim. Hopefully this works now. I kind of wanted to compare them. No. That's disappointing. Really? Okay, but let's give also Deepseek a chance here. That was strange. Okay. Maybe I'll scratch this from the video. But let's select Deepseek-r1. And what's interesting now is that we can actually see the tokens. You can see we are streaming the reasoning tokens. Okay, so it selects. Zoom in a bit. I'll use 3JS because it's a popular library for 3D graphics in the browser. Yeah, that's pretty cool. For the wind particles. All weekend, I've been kind of sitting and reading the reasoning tokens. It's so interesting. I got a few examples coming up where we're going to look at some strange reasoning tokens, I think, from some prompts I found. But here, you can see R1 is still working on the context here. Not the context, the reasoning tokens. And there's a lot of reasoning tokens. So I'm just going to let it run. I'm just going to speed it up so you can see how long it thinks for. Okay, so I'm just gonna see here. This is what I found so cool. So it kind of goes into, but wait, wind direction is a 3D vector. For simplicity, maybe adjusting X and Z components. So the user, so it kind of gets these moments in the reasoning part that just says, oh, but wait, maybe if we do this instead. I thought that was pretty interesting. But yeah, let's continue down here. Still thinking. Okay, so it seems to come to the end here because it gave us the full code. So to run this, save it as an HTML file, open in a browser, use controls, click and drag. Okay, so let's paste it in here. 159 lines, okay. Let's open it. Okay. Wow. Look at that. How cool was that? Could we change the angle? Yeah, we can. This is awesome. Okay, so it looks like the controls, it's a bit strange. They kind of, maybe if I zoom out, let's reload this. Yeah, the control setting looks a bit strange, but the wind elevation works. And open controls. We can change the speed. But they kind of messed up the control panel here. Other than that, that looks awesome, right? And look at this angle. And we can clearly see the particles forming around this. And we can rotate it. Okay, so watch from below. Can we rotate? Yeah, you can see. Opacity works. Wow, that looks cool. Okay, that's interesting. So DeepSeek was the only model that kind of completed this. Huh. Very strange. I'm kind of surprised that O1 did not complete this. Maybe if we gave them more shots, I don't know. But I'm just gonna take this as is. Maybe this was a fluke, I don't know. But that was pretty cool. And I kind of went through the reasoning tokens and it was super interesting. But we'll look more into reasoning tokens in a few more examples we have in this video. So yeah, let's just move on to this. Pretty surprising, if you ask me, but also pretty cool. The next experiment I wanted to try out was combining maybe tool use from Claude and kind of feeding it into the Deep-r1 like reasoning, I don't know what you call it, engine or like thinking. And we can kind of combine tool use from Claude and the reasoning thinking or the thinking tokens, reasoning tokens from Deepseek-r1 and see what we can kind of do with that. I thought that could be pretty interesting. So here you can see I just set up the Claude function again, but now we added a weather tool so we can check weather in different places. So we can check the weather in London. Then we can combine this using some kind of other queries and feeding this into the reasoning tokens from R1, right? So pretty standard setup here. Other than that, it's basically just the same. We just use the Open Weather API to fetch the weather, and we have the R1 DeepSeek Reasoner model. So how can we do this now? So you can see, let me clear the previous one. So if we run Python main 3.py, what is the weather in London? So we can print this, right? Print, and we should get like a weather report Claude uses the tool to fetch the weather in London. So you can see, yeah, currently in London there's a moderate rain, temperature 5 degrees Celsius, humidity level. So basically this takes the city of the query. You can see we have, where's our tool? So yeah, it's basically here, get the current weather information for a specified city. We need, there's a string type and description has to be a city. So we can change up the city here, that's fine. But what we can do now, instead of printing this, we can just create like a Deepseek. So if we have, what is the weather in London? That's not gonna work, right? But we can create an F string here and we can say weather result or weather in London. All right, we can feed that. And since Claude is gonna fetch this for us, we can kind of follow up with, is this a good day for a 84-year-old guy to go outside? He's got a bad back and a bad knee. Tell me your insights. Tell me your recommendation or something like this. So now we're gonna reason over the weather results from London. So let's try to run this now, and I guess we need to, do we have to print this? I'm not sure. I don't think we have to because we stream it. But basically the idea is that we feed the results from the API call into this autonomously. So let's see what happens when we run this now. Hopefully, yeah, we're not gonna print the results, but we are gonna start streaming so you can see. So the user is asking for today's weather in London is suitable for an 84-year-old man with a bad back and need to go outside. Let's break this down. So we're gonna look at the weather conditions, moderate rain, 5 degrees C. Let me think about each factor. Moderate rains means the ground will be wet. So you can see we kind of go through these reasoning steps. Even though we didn't have the tool to fetch the real-time data, we can just use another model to do that. So here it kind of goes over, not ideal for going outside doors today, slippery surface, cold, health risk, better alternatives, postpone outdoor activities if weather improves. And if there's no urgent need, stay indoors, today will be wise. Contact health provider for personal advice, cold, damp weather. So yeah, this was just an one example of how we can do this. And I guess we could change this up if we wanted to. So instead of using like the weather tool, let's not do that. Let's change the tool maybe. So we can just change the tool to fetch the Bitcoin price for the last 5 days, include date time, use the CoinGecko API. So instead of using like the Open Weather tool, we can just use the tool to get like a Bitcoin price or something. And then we can feed this into our reasoning part from Deepseek-r1. So let's see how that worked out. So now we can see we just import date time and we change up the function, get Bitcoin price. We have some parameters, we change it. So basically a pretty standard change. We are still keeping like the tool setup, get the Bitcoin price. Let's look here now. So Bitcoin prices, hopefully. Is this a good... we need to change this. So let's do buy, sell or hold, give a recommendation. Yeah, so let's try that. We're gonna check if we are actually fetching the Bitcoin prices. Let's do that first. So let's print this, comment out this and run this. Okay, so you can see the past days the price has fluctuated between, we kind of need all the results, right? For the last 5 days, include dates and price. Let's try that. Hopefully now we just get a result of all the price. Yeah, here you can see, perfect. That is what I wanted. And now we can kind of uncomment this and we don't need to print this anymore. So we can uncomment this and we can run this through our reasoning steps using R1. So yeah, I thought it was pretty cool. You can kind of combine different models, use different tools since, yeah, we don't have the tool calling in this model. So I need to analyze the trend. The price started high. So basically it goes through and tries to reason over the context we just fed it. So I thought that was pretty interesting. It's a pretty cool way to work around that we can't use tool calling with this model. So recommendation is to hold. The rationale for holding Bitcoin. Pricing's consolidating a tight range. There's no clear directional signal. Holding avoids impulsive decisions until a breakout above or below. If you're risk averse, monitor this level. If you're long-term bullish, minor fluctuations may not warrant action. Cryptos are volatile. That's a note. So yeah, pretty cool. It kind of got me thinking like in different ways. So I haven't really spent a lot of time thinking about these time compute models lately, but this weekend using R1 has kind of changed my mind a bit on this. And I think we can do some pretty cool stuff going forward using these reasoning tokens. As you will see soon, there's some funny stuff we can do with this. So yeah, that is how you can kind of incorporate some agency. We can start building out some small agent. Yeah, I have some ideas we're gonna do in other videos. So I thought that was a pretty cool example. Yeah, let's just move on to the next one I had planned. Thought this one was pretty fun. Now, I just want to do a prompt that kind of shows how these reasoning tokens are so fun to look at. So over the weekend, I kind of tested out this prompt. I'm going to read it for you here. Basically, it's pretty straightforward. Think of a number between 1 and 100. The user should guess it. Don't overthink it, but try to make it a bit harder for the user to guess it. So basically, when we run this now, R1 is gonna try to come up with a number. And of course, it has to use the reasoning tokens. And I had so many fun responses during the weekend while I tested this out. Because it seems to think about, even though I said don't overthink it, it kind of grows through, and it kind of reminds me of humans, right? So let's just look at a few of the tokens here now so you can see. The user wants me to think of a number between 1 and 100. I need to see. So let me guess. If I just pick a random number, they might guess it too quickly. How can I make it trickier? What reasoning was that? Maybe if I avoid the obvious middle number like 50, people often start there. Also, numbers are multi-taped to 5 or 10 are common guesses. So maybe pick a prime number. Prime aren't as frequently guessed. So let me think of primes between 1 and 100. Kind of list up all the primes. Maybe 67. It's not too high, not too low, or 73. Those are less common. Let's go with 73. Wait, 7 is also a prime. Maybe 37 is in the middle, but still a prime, or 53. Alternatively, maybe a number that's multiple with something less obvious, like 17 or 23. So it's so fun to read this. It kind of goes through this long cycle of thinking about what kind of number it should pick, even though just take a random number. So it kind of comes to its conclusion at the end here. So those have digits prime themselves. Wait, 37 is 3 and 7. 73 is 7 and 3, both primes. That's a good point. Maybe 37 is in the middle, but still a prime. Alternatively, 73 is higher. Let me pick 73. Yeah, 73 is a prime. Not multiple of 5, not too close to 50 or 100. I think it's a good choice. Let me confirm. 73, it's a prime. It's not a common guess. Yeah, that should work. All right, I'll go with 73. So it's super fun to read this, and I really enjoyed a lot of these questions during the weekend, just looking at this. So try to play around with some simple prompts like this, and just read the reasoning tokens. It's super entertaining, and it's so, for me, it's kind of maybe not human-like, but it's kind of trying to go over and think of a way that is not too easy to guess, even though any number would do, right? I guess there are some biases towards some kind of numbers between 1 and 100. But even though I said don't overthink it, I feel this was kind of overthinking. But it's pretty funny, and I just wanted to share this. But yeah, let's do a couple of more things before we call this. So the next experiment was maybe the favorite one from this weekend, maybe except from the tool calling. I read somewhere that it can be really hard for LLMs to, if we are really honing in on the training data, they kind of have to fight to escape kind of answering the most obvious thing. And I wanted to kind of put that to the test. And yeah, let's just do that. I wasn't supposed to have that, but basically we're gonna try to challenge to come too close to the training data that it has to have, but change up kind of the question at the end here. So the prompt is gonna be: the following is a famous puzzle. A man and a goat are on one side of the river. There is a wolf and cabbage on the other side. The man has a boat. The man wants to get the goat to the other side of the river. How does the man get the goat to the other side of the river? If you know the famous puzzle, you have to shuffle around. So you have to go back and forward between kind of the goat and the puzzle. You have to take something back. But here we are doing kind of a twist. So we can see if the model tries to or can break out of the training data and find a solution, even though it's really gonna struggle and wants to do the shuffling, right? So we're gonna run all three models. We're gonna run Deepseek-r1, we're gonna run Claude and OpenAI, and we're gonna see how they do here. So Claude 3.5, O1, and Deepseek-r1. So that's gonna be Python main 4.py. So I'm gonna run all models, and then we're gonna take a look at the results. Okay, so we have the results back here, and this was pretty interesting. So I read through some of the thinking here, and it's super fun, right? Because it starts out, so there's this puzzle, the kind of famous puzzle, so it has a lot of this in the training data. There's a wolf and a cabbage on the other side, so it has to go on the left bank and the right bank. Wants to go back and forward. Wait, but the goat is already on the starting side. Wait, oh no, wait. The man is left with the goat. So it kind of goes through all of this. There's a different from the classic puzzle. Wait, maybe the user did a mistake in the setup. Let me think. All are starting on the same side. So it's kind of fighting with itself around the training data because it has seen this so many times. But now the puzzle is kind of laid out in a different way. But at the end here, after going, it tries first to do this. Go right, return alone, go left, go back. But it kind of comes back to that the original problem stated has to go on the other side. There's a wolf and cabbage on the other side. The man has the boat, wants to get the boat to the other side. So it kind of comes to the conclusion at the end here, after going through a lot of tokens. So you can see in the classic problem, all are on the starting side, and the man needs to move all over to the other side. In this case, the answer would be the classic steps, but given the user's description, the answer is that the man takes the goat across, and that's it. But I'm not sure. Let me think again. If the man is on the left with the goat, blah, 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 and it kind of comes up with the answer, therefore it's safe. So the answer is simply that it takes the man, takes the goat across in a boat. Confidence score is 95 because it's straightforward. And the final answer is the man simply rows the goat on the other side in the boat. No additional steps are needed because the man presence prevents conflicts. So that was pretty interesting. And it kind of talks about maybe the puzzle was misaligned. And Claude, I apologize, but there seems to be a misunderstanding in the puzzle description you provided. So it also fights with the training data here, I think. Based on the information you're given, here's the solution. The man simply needs to take the goat in his boat on the other side of the river, since the wolf and cabbage are already there. So Claude also got it. But what's surprising here is that O1 did not get it. I've done this before. We're gonna run it one more time because I've seen O1 solve this before. But in this case, it does the... what can I tell you? Yeah, the rotation from the training data in this sequence. That was not possible, not needed in this way. But we don't get the reasoning token, so I can't tell what happened. But let's run it one more time just to look at the answers. Okay, so look how many reasoning tokens Deepseek used in this case. It's insane. It took forever, but it ended up with the man takes the goat across in the boat, and since he stays with the goat on the other side, there's no danger. So after all of those thinking tokens, it kind of ended up with that. Claude just did the same, but it gave the correct answer. Just take it over. What about O1? It's still thinking, so I'll be right back. I don't know why O1 doesn't get this. So it seems to wants to go into the shuffle again. That's pretty strange. Even though Claude and Deepseek got this. Strange. When I tried this before, I think it got it right. All models, but yeah, can't replicate it, so that's pretty strange. So I guess O1 kind of failed this one, and Claude and Deepseek got it pretty good here. The final experiment I wanted to do today was to continue a bit on the problem I created in my last Deepseek-r1 video, but now we're gonna kind of chain the reasoning tokens. I just wanted to test this. I don't have a good conclusion yet. My initial thought is that this does not work, but I can't really conclude. But let's go through the prompt here. We're only gonna feed this to Deepseek-r1. So the prompt here is gonna be, I was walking home from the hardware store with a bucket of blue paint in my hand. It's gonna be nice to get this paint on the renovated room upstairs. The weather was sunny and warm, almost too warm for me. Also, I just read in the paper that the New York Rangers won the Stanley Cup. Suddenly, I get a message on my phone, get to the hospital now. Put the clues together and give your best guess about what is happening in one sentence. Okay, so that was kind of from my last video. And the idea here is that the bucket of blue paint is a hint. The renovated room upstairs is a hint. The weather is a distraction. The Stanley Cup is a distraction. Get to the hospital now is a clue. So put the clues together and give your best guess. So my idea is that the partner is going into labor and they need to, going into labor, and that's why he needs to get to the hospital. Because of the blue paint, that could be for a nursery, for a girl or a boy, and they are painting and renovating this room. So I want to see if Deepseek is going to give that guess. But we're going to do it in like a chain reasoning way. We're going to chain the reasoning tokens. So first we're just going to run Deepseek-r1 with this prompt. And on the second run, we're going to feed in the prompt, the first reasoning, reconsider, and we're going to do the same here. And we're going to print the first, second, and final conclusion. So yeah, let's run this and see what conclusion we end up with here. Okay, so this was pretty funny. I just wanted to look at this. It did talk about went into premature labor and suffered some kind of complication. And it's talking about newly renovated upstairs nursery, hence the blue paint. So it is onto something, but the funniest conclusion is the person's partner or family member, overwhelmed with excitement from the New York Rangers Stanley Cup win, a rare event since '94, likely suffered a heart attack or a medical emergency during the renovation, prompting the urgent hospital summons. So that was the final conclusion. It was wrong, but it was really funny. So I'm gonna run it a couple of more times and see if we get a different answer. Because on the second analysis, newly renovated upstairs nursery, hence the blue paint, went into premature labor. So that was the good analysis, but let's see if we can get that to the final conclusion. Okay, so here we are looking better. So the most plausible connection is that the renovated room is a nursery, blue for baby boy. The Ranger winning Stanley Cup is a red herring, but maybe the partner's a fan. And the urgent message got the partner into labor. Okay, that was pretty funny. So let's see if we can continue with this thinking through all the reasoning steps here and see if we end up with that or it's gonna be something else. Final conclusion, the protagonist partner is going into labor, hinted by preparing the nursery, prompting the urgent message, while the Rangers Stanley Cup win either sets the timeline or serves as a coincidental event. Coincidental, okay. So yeah, I'm pretty happy with this. I'm so impressed. I think it was pretty cool. Even though it doesn't really... You kind of have to think about this for a while before you kind of came to this conclusion. There's a lot of red herrings at this set that could happen for this. So just for fun, I'm just gonna run this through O1 one time, and I'm pretty sure it's gonna get to the same conclusion. Okay, so it looks like O1 got this pretty correct too. So you're rushing to the hospital because you just learned that your partner is in labor. Perfect. Second analysis, kind of the same. Final conclusion, the strongest single sentence conclusion is that you're preparing a baby boy's nursery in the Rangers winning color. Wow, that was good. In the Rangers winning color. Ooh, that's blue, right? When suddenly you get the urgent message that your partner has gone into labor and must rush to the hospital. Ooh, I gotta give that to O1. That was pretty nice. Because it kind of combined the Rangers jerseys. They are blue with the paint. So that was pretty cool. I didn't think of that. Okay, that was pretty cool. But yeah, that is basically my 5 experiments for Deepseek-r1. And yeah, I gotta say, I'm super impressed. I'm really looking forward to playing more around with this. And it's gonna be super interesting to see where we go with these models. Because I heard some rumors that the graph on performance looks pretty good when you're kind of looking at how far you can push this. So that's going to be interesting to follow. I hope you enjoyed these few experiments too. And yeah, there's going to be more. We're probably going to try the local models soon too, because we're only doing the API. And maybe we're going to test it out on Cursor. We'll see. Thank you for tuning in. Have a great day, and we speak soon.